So this is what is called a sesquilinear form. Anything which is linear in the first variable and anti-linear in the second variable is what is called a sesquilinear form. Sesquilinear form. Okay, just something linear in the first variable, anti-linear in the second variable. So bxy is a bounded linear functional. Bxy bounded sesquilinear form that is equal to chi of txy. Yeah, someone saying something? Chi of txy, and we want to prove it's a bounded linear functional, and this is less than or equal to norm chi times norm txy 1, right? Which is the trace of that. So norm chi. This is by definition. I mean, this is the definition of chi being bounded. I have defined bxy as chi of txy. This is the definition. And that is by definition of the bounded linear functional, that is less than or equal to this, because it's a bounded linear functional and trace class operators. So then this is just trace norm, right? So that is equal to trace of mod txy1. Okay. Now I have to compute mod xy1. Okay. So what is mod txy1? Mod txy. No, sorry, there is no one here. Mod txy. Norm txy1 is that. Mod txy is nothing but txy star txy, right? Power half. Okay. So we know that this is equal to tyx txy. We have already computed that txy star is tyx power half. Okay, now txy and yt. So how this goes through? So let me compute that also. So now this is for any 4 operators. Okay, this computation is for any 4 elements for x, y, x prime, y prime in H, txy times tx prime, y prime. I mean, I write it here, but I use the different inner product and it will be all clear. I mean, when I use the physics notation, it will be clear. I mean, it will be clear means that is not the proof. It will be just clear in the notation. Okay, you have to do the same proof. You have to use the same proof because that is just notation. Okay, that is equal to. So let's act it on a z. Let us act it on z. That is equal to txy acting on. This is equal to z x prime. Sorry, z y prime x prime, right? Okay, now that is equal to z y prime. Then you have to take x prime y prime y times x, right? Now that is equal to, you have x prime y, okay, z y prime x. I have just interchanged it. So that is equal to x prime y. This is nothing but t x y prime of z. Okay, right? So this whatever the computation, simple computation we have done is txy tx prime y prime is equal to tx and y prime constant times. You have this inner product x prime y. The middle things will become just an inner product t of x y prime. Okay. So this is how they compose, these operator compose. So now we were computing t of tyx and txy. Okay. Maybe leave a gap here. So now this is equal to. So the justification comes below. Okay. Since. Okay. So this is equal to. So the middle thing will become inner product. So that becomes xx is norm x square and square root of that is norm x. So it will come as norm x times t of yy power half, meaning that it's actually actually a positive operator. What is TYY? Okay, so TYY power half. Okay, let it be. So which is, yeah. Yeah. What is it? Okay, I directly compute the trace. Trace of mod Txy equal to norm x has come out. Trace of Tyy star Tyy star is Tyy times T. That is, I mean, it is self-adjoint, and so we just have to compute them. Compute the trace. Compute the Tyy star over Tyy power half. So we can compute it on any element, right? I mean, see, this is the rank one operator. To compute the trace, you have to sum it over an orthonormal basis, the corresponding operator, T, E, and E, N. And you can start an orthonormal basis with any element. And then rest of the things will be, see, the point is the following. We have this half, which is this okay? T, oh no. This is just this, no? Tyy. See, what is this Tyy? This is okay. Tyy star Tyy. That is equal to, you take the inner product between them, which is just norm y square, okay, times just Tyy. Sorry, this is just this, right? Right? By this formula, whatever we have got, Txx equal to this. Okay, so it's this, okay. So this implies you want to take the power half. Again, there is a power half. Ty, is it just Tyy? We get Tyy, but we have a power half. Okay, what will I do with the power half? So Tyy acting on y will be, it's not norm. It doesn't get into. If you find it familiar, you can help me. I'm finding a problem here. I want to get this as, what do we want to get it? I want to get this as a norm x times norm y. I mean, I want to get this norm chi, this trace, I want to get it as norm x times norm y. That's all. Okay, I have got norm x, norm y. But then there should not be anything here. There is something, that is the problem. Tyx, is there any mistake? Txy equal to norm Txy star, norm Txy. That's right. Now you take, so this is Tyx, Txy. That's right. So that comes out as norm x, and then it comes out Tyy. That's right. But that's in the middle of that. wrong with this. This is okay, perfectly all right. Let me try with this notation, physicist notation, everything will come very nicely. So we want to talk about, so maybe I will write it here. Let me just try this, just to get it. The physicist notation for this is just this. We are talking about txy star. That's so this txy is nothing but xy, like this. Then if you have any z, it will just take this like this. But this is conjugate linear, and you get this y, right? Okay. Now you have txy, and its star is yx. Txy star txy. So this is tyx. So yx, right? And then x here. So which is equal to xx yy. 6y y, which is right. Now this is so you have to evaluate on y. You have to evaluate on y. Now this y will go away. Oh, they will take the inner product on the other side, right? Y. But you have to take the square root. No? The square root is what is giving me the trouble. Oh no, there is no square root. I'm sorry. Shit, that's the problem. Is there a square root? Exy. I'm making some silly mistake. I'm not able to find it out. Vxy equal to chi txy. So I want to define Vxy as chi txy, right? Yeah, that is how I can define. This chi txy times norm chi txy1. That's right. Txy1 is trace of mod t. That's right. Mod t is the square root of this. Absolutely correct. Everything is correct. Tyx txy